Hello, everyone. I am Alejandro Lopez Feldman. I am a professor of the Economy Department here in Mexico City, and I am going to be here with you during 4 sessions, and we are going to talk about impact evaluation. So, the idea is to talk about impact evaluation. Why is it important? What is it? And also, we are going to talk about how we can conduct this type of evaluation, some of the tools, and also we're going to cover the different tools in other sessions. Some of the things that I have to tell are technical, but I am going to try to focus on explaining how to use them, what are they used for, or sometimes we're going to have some technical terms, but I'm going to try to explain every single term so that we can have we can understand impact evaluation. And if you have any question or something that you want to add, please let me know so that I can check any of your questions or doubts that you might have. And without anything else, this session has to do with introduction to impact evaluation. I am not I do not know how much time we're going to spend, but of course maybe we're not going to be able to cover the 42 slides. Maybe we're going to continue in the next sessions. So the objective regarding impact evaluation, as you might know, we have a program or policy, and we create this policy with a specific objective in mind. For instance, increasing the income of the population who is going to improve learning. And of course, we're going to have different programs and policies. Of course, we're going to give some examples, but we have an objective, for instance, in improving income, improving health, improving learning. And what we want to achieve is to measure if the policy or program or treatment, we want to analyze
You
if
are
the
currently the
program
only person in this
or
conference.
policy reached its objective. For instance, if there was a policy trying to improve income, we need to measure if this was achieved or not. And this can be a very obvious question. Of course, we want to know if the policy works, but of course, there are some difficulties that we're going to face. Therefore, we need a lot of different methodologies. So, another thing is that impact evaluation tries to measure the changes in the variables of interest, for instance, income, health, different objectives. We can have different things, for instance, a money transfer program, and for instance, this is going to improve income or learning, or something that is going to improve school performance in children. So what we want to analyze is if the variables of interest changed, and this is one of the most difficult things because we need to estimate if the changes in the variables wouldn't have occurred if it were not for the program. For instance, if income increased, what I want to do with impact evaluation, it is related to the policy or program. Otherwise, it wouldn't have increased. So we need to be able to attribute this to the public policy. So this is one of the most difficult things to measure. Impact evaluation is different from other types of evaluations. For instance, we have indicators when we want to measure or to analyze how many people were enrolled in the program and and the percentage of the beneficiaries who receive the support or benefits. Of course, we other have some types of evaluations, process evaluations. We are measuring indicators, and we need to analyze if the program achieved these indicators. Also, we can evaluate if the program is well designed, if we knew who were the ones in charge. And this kind of evaluation, impact evaluation, is different because we want to measure the final objective and if we can attribute this to the program or to other things. So, why are they useful? Well, first of all, they provide evidence, and this is very important because this evidence is going to help us to improve a program that already exists, or if we want to improve the operation, if for instance, the objective is being achieved but not as we expected, and we need to be able to understand this to make changes. This can also be helpful, for instance, depending on our work. But for instance, if we have to ask for budget to any government body at a state or at a state level, so we have to have a solid impact evaluation so that we can say, okay, so because this program exists, the beneficiaries are able to obtain the benefits. Otherwise, they would face other kind of conditions. So this could be really helpful to request a new budget item, or to even ask for more money. And in addition, we can also say, okay, there was a program that we expected, was that we and when we started to evaluate this, then the program was not achieving its objective, for instance, improving health. But when we evaluated the program, then we realized that the health is exactly the same with or without the program. So we do not need to keep spending money on this program, and this is very useful because this has to do with limited resources. Of course, we do not want to allot resources to programs that do not achieve its objectives. So we can justify a program, and for instance, if the program is not achieving its objectives, then we need to cancel the program. So those are some of the usages. And today there is an increasing trend regarding public policies based on evidence. So not only public policies based on a need or something that we want to address, but we also have scientific evidence proving that this is the best way, or that this is going to be an effective way to use the money because it achieves the objectives. So this logic of public policies based on evidence is something that is increasing. So we need to talk about impact evaluation to be able to prove that we have scientific evidence. And the key is to be able to attribute, and this word attribute is very important because we need to be able to attribute the changes to the program. So it doesn't matter if we follow a variable, for instance, income in 2000, now in 2005 it is increasing. So yes, income is improving, but does it have to do with the program or with something else? So we need to be able to attribute to the program. So to be able to delve into it, we're going to talk about some of the technical terms. I really hope that it's clear, that the objective is clear. Impact evaluation aims at analyzing if the program is achieving its objectives, and to be able to attribute to the program the data and information that I am currently considering or analyzing. So from a general point of view, what I want to understand is I want to understand the impact because they have a variable of interest. For instance, what's the impact of a microcredit policy, or for instance, the effect of a program that with saving, and the effect of this, or for instance, the effect of training given to professors and the effect that it has on learning. So these are some of the questions. For instance, if this is a wood saving sauce and if I want to improve health, so I want to know if the users or the ones who are in charge of cooking are improving health, and if there is a program that tries to provide more training to professors and if students are learning more. So, from a general point of view, for instance, I want to analyze if an X variable has a causal effect on Y. So, if this has to do with training, if Y has an effect on this, and if I am going to receive a microcredit program, and if this has an effect on income, so X causes Y. This is what I want to know. So, in general, if I know that there is a causal effect and if I isolated this effect, I want to measure the effect. I want to measure the effect and its size. And something very important is that we need to remember that we are not talking about correlations. For instance, if two variables move in the same direction, but I want to know if the microcredit program is improving or increasing the income. So this is what we're going to be talking in this session and also in the following sessions. So it is very important to talk about causality. When do I need to talk about this and when not? And what are the methods, economic methods that we need to include, and the methods that we could use to be able to measure causality. There is a question if the evaluation is conducted by itself when the program ends or if this can be conducted in midterm. So this depends on the characteristics of the program. What we would need, for instance, if we want to conduct one in the end or in the middle, we need to be able to execute the program or the part of the program that we believe is going to affect the beneficiaries and also something that is going to be able to provide effects. For instance, a microcredit program, we might think that this is going to have some effects after 3 or 4 years because this is going to help us to measure income. If someone is going to be able to develop his or her program, maybe this is going to last 2 years, and maybe the minimum amount of time that I need to wait. And in some other cases, maybe if this had to do with training to professors, this had to do with a specific period of time, 2 or 3 weeks, when children were not in school, and maybe we can measure the effect and the impact when they go back to school. So this is going to depend on the characteristics of each program, and I really hope that when I start explaining more examples, we can analyze different methodologies and how we can apply each one in each context. So yes, this can be done in the middle or when it is starting, only if the characteristics of the program allow for it. So what I was mentioning is that I need to have this causal effect. I need to understand the cause, and I'm really sorry that I am highlighting this, but it is very important in an impact evaluation. We need to understand that if something is providing scientific evidence, we need to be able to say, okay, the microcredit program is causing the change that I am observing. And the term that we use is known as identification strategy. And we're going to analyze different strategies in these sessions. And this includes the assumptions that I need to include, the steps that I need to follow, so that at the end of the day, I can say that the effect that I am measuring is causal. So some of these strategies are going to depend, or they can be developed from the beginning, and others are not just from the design, but rather strategies that happen later. So there are some programs that are designed in such a way that we are going to have a very clear strategy, and this has to do with the programs or models that are developed from an experimental logic, and this is what we're going to talk about today. So when the program doesn't have a structure or a clear structure, we need to use econometric methods that are going to help us to have this causal effect. So this idea regarding econometric methods, it has to do with impact tools, and we are going to cover this in the following sessions. Something that is very important to consider is to have this causal effect to be able to say, okay, X causes Y. It is not about using the most complicated method. No, what we really want to do when we are conducting an impact evaluation is that we need to use the most simple method to be able to answer the question in the best way. And I would like to delve into it and help you, because what do we mean by the most simple method, and how do I guarantee that this is going to answer the question? We are going to analyze different types of information, different characteristics regarding the information that we have, and how do we use this information to answer the impact question. Well, to be able to do this, it is very important that we understand what we mean by impact, and therefore it is necessary to understand terminology. We need to be able to clearly understand what we are trying to look for, and it is going to be easier when we talk about econometric methods. So what we have here is this idea of the effect of a program or treatment in a y variable. This variable is going to be known as the outcome or result indicator of the program. This was the variable of interest. So we want to analyze the impact of the program regarding the y variable, and we can think of two different types of individuals. So y variable has to do with income, the income of the individual, and this is going to be known as I. And I am going to have two individuals in two groups, in a control and in a treatment group. So what we're going to say is, okay, this is individual Y and the Y variable regarding the I individual and super index C. So what does it mean that one individual did not receive treatment? So when we have this, is that the first individual was in the control group. So what's the income of the individual who did not receive treatment? And also we have this other individual, and this is going to indicate the income of the individual, and this individual actually did receive the treatment. So we have basically two groups. The first one is in the control group and the other one is in the treatment group. So the problem that we have, or something that makes difficult the impact evaluation, is that I cannot include the same individual because one is receiving the program and the other one is not. So we have this example, for instance, Luisa received opportunities. Opportunities is one of the most important variations in Mexico. So let's say Luisa received opportunities. So I cannot consider the counterfactual of what would have happened if Luisa, for instance, received the program. So I'm going to have a lot of different characteristics because she received this program and the benefits. But what I cannot do is what would have happened if she wouldn't have received this program. So if we the problem with the counterfactual, for instance, we have this individual. I think that this is a grasshopper or something like that, but he is choosing the path. If he goes right, of course he's going to find some different, maybe he's going to find someone, and he's going to have this path is going to have different characteristics, and if he goes left of this is going to be a different way. So once the individual chooses one way, we are not able to understand what happened to that same individual if he would have taken the other way. So that is the problem of the counterfactual. We are not able to observe the same individual with the program and without the program. And why? Why is this relevant? Well, because if we could have a parallel universe or the clone of the same individual. For instance, if we could find a clone of the individual who received the program and that clone did not receive the program, then our work would be very simple because we are going to be able to understand what happens with the individual in the program, and of course we're going to be able to analyze the performance and, for instance, the differences between both. They are identical, but the difference is that one has a program and the other one doesn't have the program. Of course, our life is going to be very simple. What happens if we analyze this example? Luisa received a program, and after 2 years the income is like this. Her children have the following scores. Her health has some specific characteristics, and Luisa received the program. So if I could observe Luisa in a different world without the program, I could analyze her health, her children's performance. So without the program, I would be able to compare the two types of realities. And the difference was that it was a program, and in the other one, it was not. So we need to be able to understand how to develop this. This is not some this we cannot do this. So we need to have a comparison group with whom I can compare the people who receive treatment. So here we have the control group, the control or comparison group. And this control group is going to help us to have a counterfactual. This is understanding what would have happened with the individuals that receive treatment if they did not receive treatment. So this means creating in an artificial way this parallel scenario or universe where the people who receive the program doesn't receive the program, and what happens with the variables of interest. So this is what we want to do to solve this counterfactual problem. So we can have some calculations regarding the counterfactual, and I am going to give you some examples. And later on, in other context and in other session, I am going to give you more examples. So we can have the idea that maybe I am going to have a counterfactual in a simple way, and sometimes these simple ways are going to lead us to a mistake. So two of the main mistakes that can be done when conducting false comparisons regarding the counterfactual is analyzing the same individual after and before the program. Another mistake is, for instance, when we say, okay, where I am going to compare a group of registered individuals or participants and non-registered individuals, non-participants. So let's see an example of the first case. So a before and after comparison, this is the same group before and after the program. So what could go wrong? For instance, we have this graph where we are going to analyze the results before and after. And for instance, we have a microfinance program. This is a program that aims at improving agricultural production. This is a program aimed at farmers, and the idea is to allow access to microfinancing so that they can improve their performance. So then we have a before, which is year zero, and this was when the program did not exist. So maybe we have this individual, and we can see that this individual in year zero This could be either an individual or a group of people. So his production was 8,000 kilograms per hectare without the program. And then here comes the government with the microfinancing program, and they and then we have observations in year one. So in let's say that in year zero we have a survey for farmers that are eventually going to receive the program, and we have a survey. We obtain information regarding different characteristics, for instance performance or yield per hectare, and then we conduct another survey in year one after the program was implemented, and we have some effects. So what we can observe now is that the same individual that in year zero had a 1,000 performance, now he says now my performance is 1,000. I, so in year one I had a performance of 1,000 kilograms per hectare, and now I have a better performance. So if we have a comparison, we would be able to see that with the program the same individual is having a better, is increasing his production. The problem here is that we do not know what's the counterfactual. We are not able to see what would have happened with this same individual without the program. So what is the counterfactual? And we do not have this information. So what we are doing by attributing the increase in production to the program, then we are just assuming that, for instance, if the program did not exist, then his production would have stayed the same. So the counterfactual is going to depend on the condition, on the specific characteristics of the program. We need to analyze the different circumstances and the place. But what happens is that in that many things change in time, and maybe it was not just because of the program. It can also be possible that maybe this individual was more productive. Maybe he met someone who makes some recommendations on how to improve his performance. So that doesn't have to do any that, and maybe he met someone else who explains how to obtain more kilograms. So if maybe Juan or the individual without the program would have stayed the same, and maybe he obtained information obtained from a friend. So what does this mean? For instance, imagine that the counterfactual, if Juan or the individual did not receive the program, he would have stayed here. And this means that the effect of the program doesn't have to do with 100 extra kilograms, but this is the difference between A and C, because without the program, the individual would have stayed here. So this is the effect of the program, and this is the counterfactual. So this is just a hypothesis. I do not know if this is a problem because I am not able to observe the counterfactual, but I conducted a survey and then another survey, and I found that he is here. So maybe the extra 100 kilograms can be attributed to the program, but I would need the counterfactual. For instance, imagine another example. Maybe the reality is that the individual, maybe there was a something related to the weather, and the individual without the program, he would have had a loss. So maybe the counterfactual is D. So without the program, due to this, to a drought, maybe he did not have enough water for rice. So what would have happened is that the individual would be located here, D. Let's assume that this is 200 extra kilograms per hectare. So because he received the program, maybe he is in A. And what does this mean? Well, this means that the program of the effect of the program is not only 100 but 900, and this is where he is and where he would have been. So what I want to point out, and there we're going to talk about the different the what a program measures and a counterfactual. So we do not want to compare an individual in year 0 and year 1. What we want to understand is the effect of the program, and the effect of the program is what is different thanks to the program. So in another scenario, the individual would be here without the program. I could say that this is the effect of the program, but this is just an assumption because I am not going to be sure. Then we need to have something more solid and not only trying to imagine what would have happened to Juan without and with the program. So I do not know what's the effect of the program. So I need to have something solid to be able to understand the effect of the program. If I am sure that this is the counterfactual, then I understand the effect of the program. So if I understand that this is a counterfactual, all of this is going to be the effect of the program. So what do I want to explain? Of course, it is not going to be simple to understand the effect of the program, but I want to be able and pretty sure that what I am measuring is the impact of the program. I want to solve the problem regarding the counterfactual. So with a before and after estimate, I am not going to be able to obtain more information. So what I did is I explained a false counterfactual, but I need to explain how we're going to solve this. So let's move forward. We're going to talk about terminology. So for instance, let's talk about a binary treatment. This is something that happens or it doesn't happen. You either have the program or you do not have the program. Some public policies, some programs, and some NGOs interventions. Sometimes someone receives a scholarship and someone receives more money than the others, and sometimes they receive money transfers, and these programs can also be evaluated and you can apply the same logic, but the example would be more complicated. So that's why we're going to keep talking about programs that happen or doesn't happen, because this is going to help us to have a binary variable. This variable is going to be 0 if the individual doesn't receive the program. And for other individuals, the individuals that are included in the treatment group or who receive or those who receive the program, then the variable is going to be 1. And then we have this second counterfactual. I could say that what I'm going to measure is, for instance, if I could do this at an individual level, we could analyze the same example regarding money transfers. Luisa received this, so what is her income because she received the program, and minus the income because she did not receive. So this is not possible because I cannot observe both parallel scenarios. So let's say that I am going to have a group of people. I have missing information and I am going to try to solve this missing information problem by measuring averages. So I am going to group people. I have the income of the people who doesn't receive the program, and I have this average. I also have the average income of the people included in the program. So I am going to consider average the average effect of the treatment. So this is the impact of the program, yes or no. This is the second mistake. We previously talked about before and after, and This would be another mistake regarding comparing people with the program and people without the program. And in general, this is going to be wrong because I am going to show some examples. So it is not just that simple as comparing a group of people with the program and without the program. I really hope that you can see this in the slides. And what I have in the slide is a group of people. So, for instance, if we had a medical insurance program, we want to know if this improves health. So what we have here are health indexes. Here we have husbands, here we have wives or men and women, and we have this first column providing information regarding medical insurances. So this is the this indicates if it has medical insurance or not. And this data provide information on the medical insurance, and we can have a comparison. We can make a comparison. For instance, we can compare the average in the control group minus the variable of interest in the treatment group. So I am going to compare this averages. So I have the average of the ones who do have an insurance and the ones who do not have insurance. So this is control group and treatment group, in this case husbands. So I could have this means difference, and here I have the difference. This is 0.31. For instance, the ones who have insurance, they have a higher insurance index than the ones who do not have insurance. I could do the same comparison. I could make the same comparison with wives. For instance, the ones who are receiving insurance, the ones in control group, and we also have a difference 0.39. Here we have women who have medical insurance, and in average they have better health. So it could seem that this comparison is providing useful information. We are obtaining information regarding the ones who have insurance and the comparison between the treatment group and the control group. So why is it a false counterfactual? Well, because we do not know anything else regarding these two groups. We did not develop the program so that these groups can be compared. We do not have more information regarding this. So if we have more information, and I really hope that you can see this in your slide. So what do I have here? Here I have some different characteristics, and not only regarding health. These are the ones who have insurance and the ones who do not have insurance. So here has to do with family income, and the ones who have insurance have a higher income than the ones who do not have insurance. So here's another variable, education. So in average, they have more education than the ones who do not have a medical insurance. So the same thing happens with wives and husbands. They have more income. So what does this mean? Well, this is providing information, and of course our groups cannot be compared. They are different because this is treatment group because it has insurance, and this is a control group because it doesn't have insurance, but they cannot be compared because education, income, everything is different, and even the household, some other variables. I am not comparing things that can be compared, and I wouldn't be able to measure this because the ones who are included in the treatment group do have a better health than the ones who do not have insurance. So I wanted to attribute this to the program, to a specific program, for instance, in this case, that they have medical insurance. But I am not sure because, for instance, it is possible that they have better health because they have higher income. So this big difference in income, maybe this will explain the difference in health. Or maybe given that they have better education, they have better health. So I really hope that everything is clear regarding the problem that we are facing, because the groups work cannot be compared. So if I only analyze the means difference, then I am just attributing to the program things that maybe cannot be attributed to the program. So at the end of the day, it is likely that better health has to do with better education, better income, and so on and so forth. So I am not going to be able to analyze the program. For instance, a medical insurance has to do with income. If I make a comparison, for instance, control group and treatment group, I would not be able to know this
You are currently the only person in this conference.
so we can see that this can be it cannot be compared just because I want to compare different groups without a previous structure. And also this can be a before and after comparison can be a mistake. So what do we want to achieve? I am going to give you another example. So how would I do this to obtain results? But if the problem, if regarding medical insurance wasn't understood, we're going to have another problem regarding textbooks. For instance, let's suppose that we have information in a certain region in the country. And so it happens that some schools use textbooks. There is a mandatory book that they need to use to teach children, and some other schools do not use this textbook. And what we want to know is if the textbook has a specific effect on children education. So I am using this example to provide more terminology. And I'm really sorry if I am including a lot of technical information, but the idea is that you can understand technical terminology so that you can obtain more, can acquire more knowledge. So something that I could measure is the treatment effect. This is the average treatment effect. So the average treatment effect is the means comparison, the one that I included in the previous slides regarding medical insurance. So here it has to do with the expected average regarding children learning given that they are using textbooks, and I'm going to compare this with the expected value, the average in the control group. This is a school without textbooks. So I am comparing educational performance and average educational performance, schools with books and schools without books. This is a means comparison, and this is very simple. This can be a problem, and we are going to analyze this. So this is not necessarily what we want to calculate or estimate. What we want to estimate is the difference. If this is a program that we want to evaluate, we need to analyze the difference. What is the problem regarding means difference? So maybe schools with textbooks do have more differences and variables, and this is known as a selection bias, because with the information that we have so far, we only know that there are some schools with textbooks and schools without textbooks. We do not know how they got the textbooks, and here we can have this selection bias. For instance, let's suppose that in schools with textbooks, these are schools where parents are involved with their children education. So they are parents who help children in school, and they help them with their homework. So because of this, because parents are involved, maybe one of them reads something or hears that textbooks are very important to improve education. So with this information, he talks about this, he provides information to other parents. So these parents go to the government and they ask for textbooks. And that's why they have textbooks. And in other schools, this doesn't mean that, of course, not every parent is involved, but maybe they are not that involved. So schools without textbooks, maybe they have a maybe the parents in this case are not that involved in their children education, and they did not ask for textbooks because maybe they are not that involved. So this is an example regarding selection bias. Schools with textbooks where some of the characteristics, and they asked for a textbook. So the problem is that just as I am telling you this, maybe the parents are involved with their children's homework and they have textbooks, and then we have a difference regarding the performance in a school with textbooks and without textbooks. So maybe we think that the effect has to do with textbooks, but maybe no. Maybe what we are measuring is the characteristics of the parents. Maybe the textbook is useless, but what we are analyzing is that school books with textbooks, maybe the parents are helping their children with their homework, and maybe that's why they have better scores. I think that this has to do with textbooks because besides the parents' involvement, they also have textbooks. But what I am really measuring is the effect of parents helping their children or not. So this is another example, the same idea regarding health. I can attribute what I am currently observing, for instance, medical insurance, but what I am really measuring is the effect of insurance on health. So this is the same idea. I attribute this to textbooks, but what I am really measuring is the parents' involvement. And we can have many examples. So we really do not know what we are measuring if we did not understand this from the beginning. So I really hope that this example was clear. And now, from my point of view, we have some variables that I do not consider or observe, and the results that I have in the variable of interest have to do with what I am observing. So if I want to to provide more information regarding the technical aspect, we are going to talk about this expression because I cannot measure this, but I would like to measure this, and this provides information of the expected value of the I variable for the individuals who received the program. What would have been the value if they did not receive the program? So this is a counterfactual that I cannot observe. What would be the performance in schools with textbooks if without textbooks? So what is the average income for individuals who received the money transfer program if they did not receive the program? So I cannot observe this, but this makes sense regarding the counterfactual. So remember that this is the means difference if I just make comparisons between the schools with textbooks minus schools without textbooks. So this is what we do when we have a means difference. So what is happening? Well, this expression that is known as observed counterfactual, I am adding this to the expression and subtracting this from the equation or formula. So the average treatment effect is not being altered with this trick of adding and subtracting what I would like to measure. So why I am doing this? Well, because if we analyze this in this way, the means difference that I can obtain has what I want to measure. This is included within the expression. What I would like to measure is what happens with schools who have textbooks in comparison with the same scenario, for instance, if they did not receive a textbook. So these two components are the ones that I would like to measure. So what happens to average income of individuals who receive micro credit, and what would have happened to these same individuals who did not, for instance, if they did not receive the microcredit, or the graph that I explained before, what would have happened with corn tons produced per hectare with a microfinancing program in comparison with the same case but without the microfinancing program. So this is included within the means difference, and this is known as the average effects, the average treatment on the treated. So we want to measure what is the effect of the program. And we also have another component. So besides this two, which is average treatment on the treated, we also have these two components when we have a means difference. And this is what we know as what is known as selection bias. So do they what do they mean? The W variable was 1 when I receive the treatment and 0 when I do not receive the treatment. So in these two groups, the program doesn't exist. I am just making a comparison between the income for the program who would eventually receive a microcredit and the average of the group that is not going to receive a microcredit. So I am comparing these two groups, both the control group and the treatment group. So a concrete example would be what I explained previously, for instance, regarding medical insurance and health. I want to measure the effect of the medical insurance, but even if if the medical insurance doesn't exist, maybe health of a specific group that would eventually have a medical insurance is different from the health from the individuals who are never going to have a medical insurance. So both groups can be different, or for instance, the same case with schools and textbooks. It is going to be 0 if it doesn't have textbooks, and some schools have a better performance, and the schools that have better performance are the ones who are going to have textbooks, and this is what we know as selection bias. Health in both groups would be different even without the program, and school performance would be different even without the program. So this bias, regardless of treatment, it provides information and it makes obvious that there is a difference. So if I have a means difference, I am going to be able to measure, but also it includes this in the selection bias. So this is what we that I already explained with medical insurance. They were different because, of course, they had different education, different income. So, of course, we expect different results. This is just a mathematical way of explaining this. I already talked about this. I am going to keep talking about textbooks, but what we have here is basically a possibility. For instance, maybe parents in those schools are more involved, and that's why they are doing better. And what do I mean by this, and how can we explain this from a more formal point of view? And these are individuals who are more involved in their children performance and learning. So even without textbooks, we would expect the same performance and a better performance. So it doesn't have to do with textbooks. This has to do with selection bias. And even this bias could have a different direction. For instance, maybe schools with textbooks have textbooks because there is a NGO and this NGO knows that these are schools in marginalized areas. So there are some things that are independent from the program. So because I do not observe this and I do not observe this counterfactual, I do not know if this is a negative or positive bias. So I am going to go back to the formula that we have here. So I cannot observe the school with textbooks and without textbooks. So I do not know if this bias is either positive or negative. So I do not know if I am I have I if this is the right counterfactual. So the only a means difference will provide information regarding the effect of the program, and this will be done when there is no selection bias. And this is not going to happen just because. What we're going to do is to either I design the program in such a way that I guarantee that individuals can be compared without the program. I need to guarantee that I can do this so that I can use a means difference. And the other way is what do I do to get rid of this and use econometric methods. So these are the objectives, the problems, because a means difference just by itself is not going to solve the problem. A before and after comparison cannot is not useful to solve a problem. And now we're going to talk what can I do depending on different characteristics. So this is the objective, of course, not for today, but during these sessions. So we already know what we want to achieve. We want to say that X effect has a certain effect on the variable of interest. If it works or if it doesn't work, I already explained why we cannot use a before and after comparison or a means difference. So one of the methods is known as randomized control trial method or RCT. So in many cases, this is known as the golden standard of impact evaluation. Why? Well, because this randomized control trial and this experimental approach is going to assign individuals in a randomized way to the treatment and control group. And if we do this in a right way, this is going to allow us to make comparisons, make means comparisons, and therefore we can have an impact evaluation. And we're going to see why and how can we do this. So the main idea here is that in a randomized way, I am going to assign the individuals to the treatment and control group. And when I do this in a randomized way, the only thing that I am going to be able to do is that one group has the treatment and the other one doesn't have the treatment. So I am going to select these individuals. For instance, imagine that we have a population that can be selected, for instance, companies. But let's talk about individuals because this is the easiest way. For instance, individuals who are eligible to receive a government program. So what I do is that I have a list of these individuals, and as a government agency, I am going to select in a randomized way the ones who are going to receive the program and the ones who are not going to receive this. So I am doing this in a randomized way. This is not just as the previous case. For instance, when I was mentioning that parents are more involved and they asked the government for textbooks. No, in this case, I, as a government, I am trying to have a program. I am going to select the individuals. For instance, from my computer, I'm going to say I have this 1,000 people. I can finance. I can include 500 people. So I am going to select these individuals in a randomized way, and I'm going to decide who is going to select the who are going to receive the program and the ones who are not. So just from my computer, I am going to select the individuals. So I have two individuals, a treatment group and a control group. So to explain this, so the advantage is that this is going to help me to include the characteristics of both groups. So what I want in this case, I have individuals with the same income, same age, and same education than the ones who are in the other way. So if I did this in a right way, I wouldn't have to observe something, for instance, with with the health program. This was not a randomized control trial because the ones who had insurance had better income and education, so both groups couldn't be compared because this wasn't done in a randomized way. So what I would expect if this would be the same case, for instance, the ones who have insurance and the ones who doesn't have insurance, they have in average the same education, the same income. So I do this by having a randomized selection. Someone is asking a question regarding the randomized control trial, but I am not pretty sure what you mean. Can you explain your question? So this has to do with the randomized control trial. This doesn't mean that we are not going to have assumptions because later on we're going to analyze the different assumptions regarding randomized selection, when can we do this and when not. We're going to delve into it later on, but now we're going to explain randomized selection. And this is a very simple selection. The most difficult part is to I really hope that you are understanding everything because the thing is really being able to conduct this and to include this. So what is the point here? Well, if I do this in a randomized way, for instance, I am the government agency and I want to conduct a program. I have the plan, but the program doesn't exist. No, but nobody knows that this program is going to be conducted. So maybe this is going to do with a concept. I am just planning to do this. So from my computer, I am going to randomly select every individual, and I think that this program is going to affect income if I already divided the eligible individuals in treatment and control. But if the program doesn't exist, but if I am just using data in my computer, what I would expect is that, for instance, given that we do not have differences regarding education, I would expect no differences in the variable that I want to include. For instance, if this is a program that aims at improving health, I would expect that they have the same health in the treatment and control group. Why? Well, because the program doesn't exist. I only selected 100 eligible individuals and I separated them into groups, 500 each. So I really hope that they have the same level of education, income, health. So if we go back to the to mathematical terms, I really hope that without the program, in average health of the program who of the group who is eventually going to receive the program, I really hope I would hope that they have the same, that the health, education, and income is same. So if I did this in a right way, then two groups are going to be in the same level. So if I go back to the same formula, when I have the experimental approach, this is going to be equal to 0. So what I could estimate with a means difference, which is this, so now I can observe that the program exists. Here I have the average health for the ones who received the program and minus the average health of the people who did not receive the program. But what I was able to control, this is going to be equal to what I would like to observe. So what is the effect of the program in the ones who receive the program? So what is happening, for instance, this control group, this artificially made selected group, now this is going to be a valid counterfactual. So I can have the control group as the counterfactual and what would have happened to this group without treatment. So the means difference can be obtained in a very simple way, and this will measure the impact. Not because I wanted or because I want this to happen this way, but because I developed this in this way. I decided to randomly select the individuals in the program so I can make comparisons. And this logic, this terminology, I really hope that you already knew this. And for instance, regarding medical terminology, and this is included in, for instance, clinical trials. I am going to select the individuals who are going to receive the pill and the placebo, and or the pill that doesn't have the ingredients. It follows the same logic, but the key here is that we select them in a randomized way. The individuals are not the ones who decide if they are going to be included in the program or not. So we are not going to explain every single detail of how to conduct this program, but basically, and the most difficult part is implementing the program. I am going to define eligible units, the ones who can receive the program or the ones who could receive the program. And then I am going to have a sample to conduct my evaluation. So, of course, I have this scenario. Maybe not the whole population is going to receive this program. I am going to include a smaller part, and here I will have a to randomly select the individuals. So, a eligible unit, this can be an individual, the effect of health. So the program is going to affect the individual. This can also be a company, a health clinic. This can also be a region or township. It depends on the program. So I would like to point out that, for instance, an individual or a company, and this can also be a township, a city. So depending on the effect that I want to analyze, and it can be difficult to have a comparison group and a treatment group. So for instance, if I want to have a program regarding individuals and the example that I mentioned before, I can include 500 individuals who are going to receive the program and 500 who are not going to receive the program. So with these numbers, it is going to be very likely that I am going to have groups and I am going to be able to make comparisons. So when I have averages, maybe the average of the variables in the treatment group are going to be equal to the variables in the treatment group. So maybe if I include regions, and if I am in a country with only 10 regions, what I can do is I can say I am going to have 5 regions with treatment and 5 regions in the control group. So these are not, this it is not going to be able to help me to have an average because I would need to have more people. So if the program includes more individuals, or if this doesn't include a lot of individuals, it is not going to be able to do this in a random way. So if the program doesn't include individuals, for instance, if this has to do with regions, of course it is not going to be easy to have a random selection. So these are some of the assumptions regarding this random selection. So as I said, the key of a random selection that works, the key of course has to do with this, but there is also something else that has to do with with the individual's behavior, and this is known as stability of the treatment value. But what it means is that basically what happens with an individual doesn't have to do with what happens with his or her neighbors. I'm going to give you more examples. Maybe this is not going to be that clear for you right now, but I'm going to give you more examples later on. For instance, if we have an impact evaluation and if we develop a random program, we need to have a baseline. And what do I mean by this? Well, for instance, a survey made in year zero, a survey before the program exists. So there is no program. I have a survey, and this survey provides the characteristics of the individuals. So this baseline is going to help me to guarantee that the treatment and control group are exactly the same, that the income is the same in average, that the education is the same, and so on and so forth. So, for instance, I really hope that you can see data here in the slide. Here I have different characteristics of the households, and here I have, for instance, townships that are going to receive the treatment or the population, and here I have the country group or the comparison group. And here I have, here we hope that these differences are not statistically significant. We do not want, for instance, the age is the same, the age of the spouse is the same. So this was done in year zero, where and the program did not exist in year zero. So I want to randomly have a control and treatment group, and before I launch the program, they are the same amount of land and everything else. So this means that I conducted that this was that this is random, so that I can have a means difference or a linear regression, and we're going to talk later on. Maybe you already know what is a linear regression, but right now this is not important. We just need to have a means difference. Well, because I already analyzed and I already saw that the control and treatment group are the same before launching the program. So if this is the case, then I can have the means difference. This program includes the same information. This was a program who wanted to have some effects regarding health expenditure. So this is the variable of interest. How was the health expenditure? This is in American dollars. And we can see here that this was pretty much the same without the baseline. There is a small difference and it is not statistically significant. And this is also a follow-up survey. I randomly selected the individuals. I had a control and treatment group. I launched the program and applied the program, and after some time, and it would depend on the characteristics of the program and the characteristics of the population. So I conduct a follow-up survey. Maybe the program is going to exist, but I can conduct a follow-up survey. It is the same variable, health expenditure. And now I'm going to analyze the treatment group and the control group. The program in this case was trying to complement, or a program who regarding health programs. So what we hope here is that people decreased the health expenditure, and the ones who had this program, and this is something that really happened because they are not spending that much money, the ones who are in the treatment group, than the ones who are in the control group, and this difference is statistically significant. So this means that in this case I can say, okay, the effect of the program is this amount minus 10.14, because the groups were able to be compared. When the program was not applied, the y variable was the same and the difference between both was zero. So now that the program exists, I can have the control group as a valid counterfactual. So I can say that this treatment group without the program, I think that they would be spending the same amount of money than the other group. So what they are expending, or what the program is doing, is that I am saving $10.14. So why can I do this? Well, because I randomly selected the individuals in the program, and let's suppose that this was accomplished in a perfect way. So when can I use this random selection? We are going to see some problems that have to do with this question. So one of the most obvious ones is when the budget doesn't allow to provide the benefits to the population. So I have scarce resources. Only 50% of the population can receive the program, at least in this moment. So, what do I do to be able to apply this program? Well, I can just include half of the population in this program. And given this, then I can say, okay, I can use this circumstance. I am going to make a random selection so that half receives it. And this is going to solve my problem, because I am going to solve who is going to have this. This is a random selection, this is a random process, and I also have the tools to be able to evaluate the program in the future. Another scenario where we can use random selection is sometimes the characteristics of the programs are such that I'm going to do this in a, for instance, I'm going to start in the north, and then I'm going to move forward until the whole country receives the program. But because I am going to do this in the north, I can do this in such a way that we also have a random selection. And after I am going to include the whole country. So I can do the control and treatment group. Eventually, everyone is going to receive the program. And once they receive the program, then I would not be able to continue doing this evaluation. So these are two natural ways. One, when I cannot include everyone in the program, and the other one when I am going to do this. And experiments cannot be applied in every single case. And one of the problems has to do with ethical limitations. When the program is not enough, I can solve ethical problems, because anyway, I wasn't going to be able to include everyone in the program, so I can use random selection, and this is going to depend on the justification. There are some other ethical problems. For instance, if you know that the program is going to work, or if you think that the program is going to work, then you need to include everyone, and you do not need to be playing around saying, okay, I'm going to include some people and some individuals. And but if the program is not going to be enough, then I need to make a random selection, and this is going to depend on the characteristics of the program. So there are some other limits, and this has to do with assumptions. One, and this has to do with contamination in the control group. So let's suppose that this doesn't happen. Let's suppose that we do not have this in the control group. And what do I mean by this? It means that someone who was not supposed to receive the treatment receives this. So let's say that someone who was in the control group ends up receiving the treatment. There is a microcredit program who was only supposed to reach a certain amount of individuals who were previously selected, but some of these individuals is aware of this program and wants to be included in this program. So he or she makes something, and therefore he or she ends up in the group. So therefore someone else is included in the program. And this is going to be a problem, because I am going to measure the income variable, for instance, and maybe he has a better income, and I am going to think that maybe the individual did not receive the program, but he did in the end. So I need to be very, very careful. I am going to include more, I am going to talk about more problems. We are going to end there, but we are going to see this in other sessions, and we are going to finish analyzing this problems. And the other thing has to do with limited duration, and this has to do with people or researchers trying to understand how the individuals are, and this is going to be temporary, and because they know that this is going to be temporary, then they behave in a different way. Because so this is what I meant a moment ago, because we have to be very very careful. This is going to be, it is easy to make a random selection, but if the people realize that they were included in a random selection, then they would behave in a different way, but in a temporary way. And of course, the change is not going to be permanent. Another problem that happens with these random experiments has to do with how specific the program is. And in literature, we have had a lot of experiments, and this has been done in control situations. So in that specific context, and in many contexts, experiments can be very very specific. So what does this mean? And this means that they're only going to work in the context that they were designed in, or for the region that they were designed. So I am going to say something regarding impact evaluation. I am going to learn something, a solid piece of information. I'm going to be able to understand that this is the impact of the program. But if there is something very specific and something that cannot be copied, then this is not very useful in terms of the public policy, because what I learn cannot be applied to other contexts. So this only applies for a certain community in the mountains in a specific country, but these results could not be generalized in other places because they were obtained from a specific context. And maybe this was a very useful evaluation, but this cannot be generalized, and this cannot be copied in other contexts. So this is what we know as external validity and internal validity. So something that was very useful, but something that I cannot extrapolate. There are there are other problems. I think they are four or five, but I think we have only a couple more minutes, so I would like to leave them for future sessions. Actually, for the next one. This is going to be on Thursday, and I have a question here by someone. Let me analyze the question, and I think it's better if I just answer your question in the following session, right? If you think this is clear, if you agree with this. So I really hope that this session was very useful, and so I'll see you next Thursday in the following session, and I will answer your question next Thursday. Have a great day. Thank you so much.